6 institutions, including at Kanpur where you were and signal processing. At that time, 1970, a promise of 1 crore per year for 5 years. Now, some successes came out of it which more than justified the expenditure. But for several people, there were too many zeros. They're not accustomed to handling such amounts of money. So management was the failure. But fortunately, there were individuals at Delhi, for example, where a world-class sonar was developed by Paul Raj, which helped. So there are different areas. And 2 points I want to make. Each decade came not only with a change in research fields, but also a change in the mode of research. When I started out, it was the MIT pattern where a professor did his own research work, and his students, each student did a different topic that you suggested. So it was all in isolation. Then I went to Stanford, and the semiconductor people worked in teams, you see. And I began to think about, is that valuable? And then in the beginning of the 1980s came VLSI, where people had the dream at that time that you could have a chip with 1 million transistors on it. Okay. They thought that was an impossible dream. But they felt they could do it. Stanford set up something called the Center for Integrated Systems to collaborate with industry on this. But the question came up, if you have a chip with 1 million transistors, what are you going to do with it? You know, the applications have to come in signal processing or image processing. We have a lot of data. So I was involved in that project also. I helped make the presentations to industry why they should donate money to Stanford. But then I had to, justify this. I knew nothing about VLSI or integrated circuits and so on. So we started with a group of students. Actually, 2 of them happened to be Indian, Jagadish and Sailesh Rao. And we started from scratch, just reading together this new jargon of circuits and so on. Fortunately, there was funding for it. A colleague in computer systems, Forrest Baskett, who's well known, in integrated circuits, Jim Meindl, and me, we had the first contract from DARPA, which is the major funding agency for new research, to do this. And the joke used to be that VLSI is a good area because what is VLSI? Very large source of income. That's what the jealous other faculty used to tell us. Anyway, you see, but we made some contributions. We said applications on signal processing. And we said, well, if you have a lot of transistors on this chip, you can have local communications between them, so to increase the speed, and modular architectures. These are easy to build. So how can we build signal processing architectures of this? They're called systolic arrays. So we had 3 theses in this area, 5 or 6 later, but the first batch of 3 all got hired by Bell Labs in 1 year. And the recruiter from Bell Labs said, his boss said to him, 3 from the same professor in one place. Well, the good side was he said, well, anyway, they said Kailash students, by the time they graduate, they already do 3 PhD theses. So we are getting 9 times the value. But anyway, they said, don't do it next year. But anyway, so Sailesh went to Bell Labs, and this is an interesting story. He was in a group, more mathematical group in Homedale, though, which is more applied than Murray Hill. And they began to hear, this was the era of HD TV. The Japanese were dominating the electronics industry at the time. So the US thought that HD TV will give them a lead. So there was a big push for that. But the engineers were not able to design an efficient enough chip for HD TV. The power was too high, the area was too big. Sailesh heard about this, and he said, in my thesis, I had some ideas for doing this. So he and a colleague of his, an Iranian called Mehdi Hatamian, who is now at Broadcom, said, we should think about it. They proposed to their boss. Boss said, no, you have enough work to do here. So as in the usual story, in their evening time and later, they began to work on it. In a period of about 6 months, they came up with a chip. I forget the numbers now, it was on the first page of the Bell Labs newspaper. I think, say, 2/3 of the area, 1/4 of the power consumption, such remarkable numbers. Okay. By 2 kids who have no experience, and here are people with 10 years experience who are unable to match this. So gradually people would come to them from outside. Our chip is the most important chip in the history of Bell Labs. You please help us to do this. So they did this attempt. And they said, why should we do this on our... And they got promoted. They became distinguished member of the technical staff, but it's still a salary. Why should we do this for Bell Labs on a salary? Let's go out and do it. So Bell Labs said, no, don't do it. We'll promote you and so on. And that's when they made them distinguished member. And they said, if you go out, we're not going to give you any work. However, after about 6 months, they left anyway. And sure enough, Bell Labs had to give them work. So they started a company called Silicon Design Experts, Inc., which eventually got acquired by Intel. So, again, the mathematics helped and led all the way. So that was my first taste of getting students to work in teams, which is and I believe that's actually the way to go, because universities are intelligence amplifiers. What's the point of my doing my own stuff by myself? That's one reason I won't go to Bell Labs, because though they tried to tempt me, because you're working by yourself. Whereas you give an idea to a student, 2 days later he comes back with some results on it or a new idea, and this work gets multiplied. And when you have teams, they interact with each other, as all of you know. By and large, in most institutions, you learn more from your peers than directly from the professors. So that teamwork thing was not so well known on the mathematical side of electrical engineering. You're all sort of loners. So then in the sensor array processing area, we had similar teams. Paul Raj came as a postdoc to me, research associate. And those ideas eventually led to what is now a very hot area, MIMO, multiple antenna communications and wireless. Every handset has at least 2 antennas on it, and the base stations have more. But I want to talk about semiconductor manufacturing, as I promised in the beginning. Now, this came in the 1990s in a somewhat indirect way. I mentioned that I had also done work in various mathematical things, because you come up with mathematical challenges in the course of using these things, and so we would do that. So I would give talks at math conferences, and in 2 or 3 of them, I met a Professor Ausland, who was a distinguished professor of mathematics at New York University, well known. But he had an interest in applications. He was what I call a streetwise mathematician. Most mathematicians, to talk to them, you have to speak in their language. Auslander was. So he said to me, I like your work, and I'm going to be the director of the math group at DARPA. So when I go there, please send me a white paper, and I'll support your work in mathematics. That's great, because in mathematics, you get $50,000, $100,000 is the maximum you can get. DARPA, the minimum contract is $500,000. Because they only select a few. They don't want the overhead. Yeah, like VLSI. So DARPA, Defense Advanced Research. They funded the internet, stealth aircraft, and so on. That was good, but I didn't hear from him. About a year later, I get a call one day, pick up the phone, says, Tom, this is Lou. I said, Lou, why have you been? He says, well, I have good news for you and bad news. Good news is I'm finally at DARPA. There's a lot of paperwork in all governments. And he was a highly paid professor there to match his civil service salary. He said, the bad news is I have no money. My predecessor has given it all away. Moreover, there's a reorganization